agora vê lá qual você tá caso aqui antes. With 200 million.
The shortwave reception on this radio is surprisingly good, but there's a major problem, and that is that the entire shortwave band is on one band, which means that when you're trying to fine-tune into one station that is surrounded by many, and in the evening that's what happens, it's very, very difficult to actually get that one station. You've got to have almost surgical precision to get that station coming through clearly. It would be very useful if you had some band spread or some fine-tuning. Now, band spread is something that you find a lot on those world receivers, where you not only select shortwave, but you select, for example, the 41 meter band, and that little strip over there, which is the entire 41 meter band on this radio, gets spread across the entire scale, so that when you are tuning on the 41 meter band, you are literally getting this the stations spread apart, which means that you can hone in on a particular station, because the next one is, let's call it, a centimeter or two away from that particular position on the dial. That makes it easy. This thing is a nightmare. Very, very difficult. It's very clear, but very difficult to fine tune into a station. So adding fine tuning to this radio and to any other radio that you have this problem with is probably going to be useful if you want to use the shortwave band. Surprisingly, shortwave is actually quite active, unlike some of the other bands on the radio spectrum. So how do we go about doing that without actually cannibalizing this radio? I don't want to turn this into a Frankenstein. I want to make it as simple as possible. And also, very importantly, whatever I do to this radio, I want to make it reversible, because some people will get this in the future and they don't want these little add-ons because they want it exactly the way it was in 1957 or whenever this radio was released. So it's got to be reversible. The fine tuning would be that you would tune to an area and then you would have a separate tuning that would allow you to go left and right of that position. So you'd be able to tune slightly up and slightly down, which means that if you've got like 5 or 6 stations there, you'll probably be able to sweep across them separately with a lot more precision than you can with the main tuning control. And doing that is not really that difficult. Let me explain. You see, when we select shortwave, all we're doing is we are tuning the oscillator to the frequency that we want. The tuning circuit, the oscillator circuit for shortwave, is actually very simple, and it's quite easy to get rid of all the stuff we don't need here to be able to see it a lot clearer, like that, and it looks a lot simpler. This is the oscillator circuit. It's got a coil, it's got a trimmer cap, it's got the variable condenser, half of the tuning condenser, the other half, of course, is at the front end. This is really what we tune. This is the only part that we tune when we are looking for a station on the dial. So the problem is this thing has got a very wide range. It's going all the way from 4.7 megahertz to probably 16 megahertz. And if we can put this in a particular position and just add a small adjustable condenser here, we'll have a solution. And the beauty of this is that capacitors add when you put them in parallel. So all we need to do is put a capacitor here, another one, like that. And of course, the total capacitance of this one will be a lot smaller, more in the range of 30 picofarads than it is, what is this, 15 to 507. So you want a very small capacitance which will add to whatever you have selected there to give you a fine tuning. And this, as I said, is very easy to do. And my whole purpose was to create this variable capacitor, this trimmer for fine tuning on this radio without making holes in it, without adding more stuff to it or removing stuff from it. And I found the perfect way to do it. I'm so chuffed. But let me show you how we can actually fine tune with a more conventional tuning condenser that we adjust to make a small value trimmer. So here's the overkill solution. We take one gang of a tuning condenser that I got from a radio. I'm going to measure the capacitance across it. And if we take it to minimum, we get about 17 picofarads. And if we take it to fully meshed, we get about 524 picofarads. Now that's far too much. I mean, this is really duplicating what the other condenser is doing anyway, the half of the tuning condensers. So we can actually reduce that quite significantly by putting a capacitor, a small capacitor, in series with that. And this is precisely what I've got here. This is a 22 picofarad capacitor, and it is connected in series with that variable capacitor. So between here and there, we have a variable and 22 picofarads. Now, if I measure that, now there will be all sorts of stray capacitances as well, but it goes from 22 to 8. So we've got a range of about 14 picofarads on there. And I'm going to put around the center. Now what I'm going to do is I'm going to connect these crocodile clips. This one goes to ground, so I'll connect it to there. And this one goes to the connection point of the oscillator condenser over there, the half that changes or adjusts the oscillator. And this one I will connect to that end. Now let's see what we get. I'm going to put the volume up. See that? It's all very busy. You can hear it. So if I just leave it there, watch this.
Satellite somewhere between Mars and the Moon. That's more. Brown is the ultimate.
Perfect. Perfect. Now the problem is, how am I going to get that inside the radio? Well, the answer is I'm not. All I need is to create a variable capacitor that'll give me, but let's call it 0 to about 12 or 15 picofarads, that I can adjust from the outside without going into the radio, that I can do quite easily. And as many of you pointed out, I've got a perfect solution there with the antenna tuner. The antenna tuner that is really made for the long wave and medium wave, and it's absolutely useless on shortwave. It is now going to become our trimming condenser, our fine tuning for the shortwave. Let me show you what I mean. Watch this.
If we push this further, we may something. The vision was not clear. It was not tranquil. It was.
See that? Main tuning, fine tuning. Now, how was that achieved? Let me show you. It's very, very simple. Let's remember what we had here. We'll be using one half of this tuning condenser. The one side is connected to ground. The other side was padded with a very small capacitor to reduce the effect of that capacitance. And that went in parallel with the section of that tuning condenser that is on the oscillator. We've got a spindle here which makes these plates rotate and increase and decrease the surface area that is parallel to the stator section. And that's how we increase and decrease our capacitance. Well, we've got something similar with our antenna tuner. We've already got a spindle, right? We've got a spindle. We've got ground over here. So the best way to do that is to create two plates that move in parallel with each other when you rotate that spindle. And here's the first one. This is the bottom plate, and this bottom plate is a 3D printed element with two clips on here. Those clips clip into this bottom support here. The surface is covered with copper tape, the self-adhesive tape, which folds around and down the back so that when I slide it into here, it actually makes ground. So this copper tape touches that element and becomes ground. So I've made an extension of ground along here. And what I've done is I've put a coating of, or a layer of self-adhesive packing tape on here to keep it insulated. We don't want this plate to touch the other one we're going to make. And this just slips in there. Very cozy. But for a capacitor, we need two plates, right? We need the bottom plate and the top plate. And this is the top plate. This plate, let me show you. It's going to slide in there. It's going to clip in there. And there are two holes in there into which these two little things, these two little protrusions clip in. The bottom is covered with the self-adhesive copper tape again. is a little band of solder across the top to make sure that all these plates are in perfect electrical connection to each other. And there's a little wire, that one, that is soldered on there, which goes out here, and this is the one that makes contact with the top plate, and this thing fits like that. I'll probably have to put a little dab of glue to make sure it stays in place, but that's the way it works. And then what happens is, let me take it out again, this is connected electrically inside a shielded piece of cable. I'm just using the center connector here, and it comes out at the bottom. The shielding is not connected to the top at all. What I've used this shielding for, and is going to be soldered to the chassis, to the ground plane or the ground of the chassis on the underside, is to ensure that the signal going through here is not affected and does not affect the signals going through these two wires from the ferrite antenna itself. So this is going to slide in here through that hollow all the way down, and it comes out the bottom. And now at the bottom I need to solder this to that that half of the tuning condenser. The ground is already here. Okay, so this is how this thing works. I need to put something in there to make sure that it fits snugly, and what I'm going to do is I'm just going to cut a bit of this string and just use it in the holes to make sure this thing fits tightly in there. And this is what we've got. We've got two plates together here. When I stuck this in, I had to lift the back a bit so that it didn't flip up. It has to lean in as much as possible to the front to get the two plates as close together as possible. And what we've got is about 20 picofarads when it's on max. And now if I rotate away, I'm left with 6. So we've got a difference of about 14 picofarads, which is about right. That's what I think we're going to need here. Probably a little bit more than we need, but there we go. We've got ourselves a fine-tuning condenser. Now, bear in mind, this thing works both ways. It goes that way. When the rotator is perfectly anti-clockwise, that's slightly lower on this end because it's the thing is not perfectly centered. When I turn that way, I go to minimum capacitance there, and then when I keep turning, I go to maximum capacitance there. So we've got two positions where the fine-tuning works centered on that point there. In other words, I could go from, I think it's about from 4 upwards and from 4 downwards, and I get practically the same effect. So I know that my fine-tuning really only works halfway on the little rotating knob over there. But as you saw, this thing works. And I've had to do very little to make it work. All I need to do now is solder this to that tuning condenser there on the underside, and I'll solder this ground to a convenient ground point that's on the underside as well. And that's it, we've got it done. And there we have it, soldered on the underside. Here's a convenient ground point, a chassis ground point. So I soldered the sleeve or the shield to that, and the condenser wire goes to in parallel, so connected to that solder point over there. And folks, there's our fine tuning. What I did do is I placed it about halfway, okay, where the effect would be the same to the left and to the right. And I realigned the RF for the shortwave so that it shows accurately on the dial. So what we know now is when we put this halfway, and I know what the marking is on that point over there, I know that my dial accuracy is practically perfect. So I would tune to a particular point on the dial where there's a lot of activity, and then I could go left or right or the other way around. I could shift away from that center point and be able to fine tune to a particular station that I'm interested in. And as you saw in that experiment I showed you in the beginning, which was recorded with this in place already, in a previous iteration, you can actually get across quite a few stations in one position of the main tuning dial here, or the main tuning adjustment. Now, there is something you've got to bear in mind, and it's probably easier to see that when we focus in on that tuning condenser over there. If I am at the end of the dial where the tuning condenser is fully meshed. So in a position like that, okay, that is maximum capacitance. So we know we've got about 500 picofarads at that point. Okay. Now what happens if I adjust this guy? Well, I'm actually adding at most about, 15 or 16 picofarads when it's in that position, okay? And that is, let's call it 0. So we have a very small add-on to that capacitance. So the range of adjustment is fairly small, okay? Now what happens if I go the other way? What happens if I tune to the high frequency right at the top, 14, 15 megahertz, where this tuning condenser is practically open, unmeshed, very little capacitance on there. Now I go and add, 14, 15 picofarads. That could well be a very big percentage of that capacitance there, which means that my tuning range, my adjustment range is very, very big. It could actually be too big, one might argue. So effectively, the range that you can tune across in the fine tuning depends on where you are tuned on the main dial with the main tuning condenser, because it's a percentage of that capacitance that you're adding on here. And the lower the capacitance is on the main tuning condenser, the higher the percentage of this add-on will be. But that's one of the shortfalls. You don't have the same tuning range or adjustment range, whether you're on the low end of the dial or the top end of the dial. But hey, I'm happy with this result. This is good enough for me. And I'm certainly glad that I don't have to go and get too crazy about how to add this fine tuning in here. I was thinking of some really crazy ideas with a varicap diode or something similar. As I mentioned in the previous video, I actually thought of a stepper motor turning a very small tuning condenser. But hey, I like this solution. It's practical, it's mechanical, it's perfectly reversible. And this is the result of asking you guys for help, because a lot of you, many of you, pointed me straight to that ferrite antenna rotator. And that's where I'm going to leave you now, with a far more useful shortwave receiver, which this thing was definitely not really intended to be. It's not a DXing set, but it certainly makes life a lot more interesting. I actually tuned into the amateur band and the 40-meter band, and I used my external SSB decoder to listen to some of the amateur band communication. So it is very, very precise, and I like it. I like it a lot. And I hope you like it as well. And if you do, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon, PayPal. Once again, thanks for watching. Bye for now. And most of all, stay safe.